Let's start with paper number 4, variant 1, 2021 Beijing. Okay.
Yes, sir.
Okay. Okay. A skydiver of mass 76 kg is falling vertically in still air at t is equals to 0. Skydivers open his parachute in figure 1.1. The speed time graph for the skydiver from t is equals to 0. Use figure 1.1 determine the deceleration of the skydiver immediately after the parachute opens. So first you need to find out that at which specific point skydivers open the parachute.
At 3.
3 seconds.
Yes.
Okay. So actually a skydiver is falling vertically in still air at t is equals to 0. So at t is equals to 0, basically skydiver opens his parachute, right? So it is mentioned in our first statement. So at time t is equals to 0, the skydiver opens his parachute, right? So it means if we exactly find the initial position, so this is the initial position. And this point is equals to 52, 50,
58.
yes, 58. So the starting point or the initial speed, which starts when the skydiver opens the parachute, is 58 meter per second. And after that, it becomes constant after some time, or we can say that. So we need to find out the deceleration of the skydiver immediately after the parachute open. So we need to find out the immediate deceleration. So let's suppose if we take a starting point 58, then we will take any other closest points. Let's suppose round figure that is 50. So these are the 2 points because graph is a uniform curved line. So rate of acceleration will be constant, right? So it means that deceleration is equals to final velocity minus initial velocity divided by change of time. So initially we take 0 and then we take this point which is equals to 0.2. So what is the final answer?
And negative 40.
Negative 40. And we know negative sign is just for, we use negative sign just for the deceleration. And in marking scheme, their answer ranges from 35 to 43. Because they ask immediately after the parachutes open, so it depends upon the student that which or how the closest value we are taking from the graph. Okay, second part, the force due to air resistance acting on the skydiver immediately after the parachute opens. So now we need to find out the force. That is very simple. The mass of the skydiver is equals to 76.
76.
Yes. So what is the formula to calculate the force?
Mass into acceleration.
Yes. So F equals to ma, that is 76 multiplied by 40.
And 3040.
3040. Explain in terms of the force acting on the skydiver, his motion between t is equals to 0 and t is equals to 6 seconds. So we need to find out the force that those forces are acting on the skydiver when its motion is between 0 to 6 seconds. So 0 is the starting point and 6 second is the last point. So we need to explain all the forces which are acting on the body.
At t equals to 0, the gradient is steeper, so the acceleration is greater.
Okay.
Deceleration.
And what about the forces
So
related?
air resistance acting on it is greater.
Yes. So we know that at t is equals to 0, air resistance is greater. And air resistance is greater than weight. We know that weight is acting in the opposite direction. And after some time, air resistance starts decreasing, right? And air resistance will decrease. Air resistance will decrease. With decreasing speed. And finally, last part of the graph, that graph is a straight line. So that straight line shows that the straight line in the graph shows that which is starting from around 3 seconds to 6 seconds. So basically this part represents the terminal velocity of the body where weight and air resistance are equal and opposite to each other. So this part represents the terminal velocity. So when weight is equals to weight is equals to the air resistance. Body will move with terminal speed. And the last part, explain why opening the parachute cannot reduce the speed of the skydiver to zero.
Because the skydiver is still in motion.
Yes, it is in motion, so it means air resistance is continuously acting over it, and there is also a force which is acting in the downward position, that is weight. So both forces are still acting on the body. So that's mean speed will not be zero when the parachute open, or it cannot reduce the speed. So we can write it as because of air resistance, also weight of the body will act in downward direction. And if we consider a zero speed, so at zero speed actually happens when there will be no air resistance. There is no air resistance. So then it is possible. If there is no air resistance, so then speed will be zero. Okay, question number 2. Okay, in question number 2, figure 2.1 shows a wooden trolley of mass 1.2 kg at rest on the rough surface of a bench. A ball of mass 0.52 grams travels horizontally towards the trolley. The ball embeds itself in the wood of the trolley. The trolley moves with an initial speed of 0.65 meter per second. Calculate the impulse exerted on the trolley.
So, sir, will we use impulse equals force into time?
Okay, so according to that, it will be equal to rate of change of momentum, or we can say that a force into time. So we have the speed of this trolley and the mass of a ball, and wooden trolley has a mass of 1.2 kg. So 0.065 is the speed, and next we have the mass, which is equals to 1.2, or we use the second form of this impulse. because they are asking about impulse. So again, the time period is very much short. So that's mean we just need to multiply this mass, which is equals to 1.2 multiply by 0.065, that is the speed. And when time is not mentioned in the question, so it means they are talking about a single second, because the time period is very much short during the context. So that's why we just multiply the uh, mass into the velocity to calculate the momentum. So that is the value of the impulse. So 1.2 multiplied by 0.065 is equals to,
0.075.
okay, 0.075. And the SI unit,
Newton kg per meter?
kg, and for speed, meter per second, right?
Yes.
So 0.075 kg meter per second. So in the question of impulse, most of the time they don't mention the value of the time. So you just need to find out the simple value of momentum p. Okay.
Yes.
And part two. So the speed of the ball as it hits the trolley. So we need to find out the speed, and we have the value of momentum, and we have the value of the masses of both bodies. So any idea to calculate the momentum?
Do we subtract the masses?
It will act like this. Let's suppose if you remember the law of conservation of momentum, I think yesterday we talked about this. So
Yes.
actually, we need to use the law of conservation of momentum. That is the mass of body one plus, or in simple word, momentum before collision is equals to momentum after collision. So let's suppose if we are using u1 for the initial speed of body one and u2 for the initial speed of body 2, that will be equal to mass into velocity after collision, mass and velocity after collision for second body. So this is the concept of law of conservation of momentum. So initially the trolley is at rest, right? So it means that for trolley, let's suppose if we consider the trolley as M1, so let's suppose trolley is M1 and ball is M2. So the initial velocity for ball is equals to U2, and the initial velocity for trolley will be equal to U1, right? So let's suppose the initial velocity of the trolley is equals to 0, because trolley is not moving, only ball is going to move and hit the trolley. So it means the initial velocity of the trolley is equals to 0 and mass is equals to 1.2 kg. So this is the initial momentum for the trolley. And if we talk about the ball, so they are talking about the speed of the ball as it hits the trolley. So it means we need to find out the speed at which it hits the trolley, and mass of trolley is equals to, sorry, the mass of ball is equals to 0.52 kg. So this is the initial condition, right?
Yes.
So if we consider the values of the initial momentum, so mass 1 is 1.2. So 1.2 multiplied by 0 plus mass of the second body is 0.52.
Sir, will we convert 0.52 into kg?
Yes, we need to convert into kg, that is in grams. So you need to convert into kg. So that will be equal to 0.00.
5.2 times 10 to the power 4.
Yes, minus 4, right?
Yes.
So 0.00052, and the initial velocity of the ball is, we need to find out that value. And what about the final momentum or the momentum after collision? What value we use in this situation for after collision or the final momentum?
0.075.
Yes, because we already calculated the impulse, so that is the total momentum. So now just we need to divide this 0.00052 on the right hand side, because 1.2 multiplied by 0 will be equal to 0. So what will be the final value?
As 144.23.
Okay, so 144.23, and we are finding the speed, so that will be equals to meter per second. And if we consider the round off value, actually most of the time in marking scheme, they used to write the answer in two significant form, right? So that's why they round off the value, and that round off value will be equal to 150 meter per second. So there are two significant figures in the answer, that is 1 and 5. 0 is not significant because zeros on right hand side are not significant. So that's why most of the time they use the concept of the significant figure to round off the answers, right? So don't get
Yes.
confused. Just remember the concept of two significant figure while checking the answer from the marking scheme. Okay, so as the trolley moves across the rough surface, it slows down and stops. Explain in terms of the work done, the energy change that take place as the trolley slows down. So we need to write with the reference of the work done. And the second reference we have to take over here is the reference of energy.
Sir, would the energy change be from kinetic to thermal?
Kinetic to potential.
Thermal?
Yes, because there when it slides over the rough horizontal surface, so due to friction there will be a thermal energy. So that is the concept of energy. And what about the work done? Okay, so if we start with the reference. So work is done. So basically work is done against the friction, and when trolley starts moving on the rough surface. So on rough surface, kinetic energy decreases or it will convert into the thermal energy, right? So we are getting thermal energy in the result of the conversion of kinetic energy, right? Any confusion?
No, sir, it's clear.
Okay. Okay, question number 3, part A. Explain in terms of molecules why liquids are very difficult to compress.
The liquid molecules are closer together than gas.
Yes. So liquid molecules are close to each other. Liquid molecules are close to each other as compared to gas. And one more thing, in most of the past paper, if you notice that this question related to the term of molecules are mostly repeated. So this concept is mostly asked in past papers also in exams. So this concept is important. They mostly ask about with the reference of molecules, explain pressure, why pressure increase, and explain with the reference of molecules, why gas is easily compressed as compared to liquid. So this question is mostly asked by the examiner in your exams. So the second concept, well, first concept is liquid molecules are close to each other as compared to gas molecules, and the intermolecular forces are stronger as compared to gas. Okay, so part B, figure 3.1 shows the device that uses liquid pressure to lift heavy boxes, and the boxes are lifted by pumping oil into the cylinder. Okay, so this question is related to the pressure. And the force downward on the piston due to the air above the piston combined to produce a constant force of 8800 Newton. So we are having a force of 8800 Newton, and the pressure of the air is 1.5 exponent 5 pascals. And the cross-sectional area of the bottom surface of the piston is 0.016 meters square. Calculate the pressure of the oil at the bottom surface of the piston. So we need to calculate the pressure at the bottom of the piston. So you got all the values, that is the force which we are applying on the piston and the pressure of the air which we are getting and the cross-sectional area of the piston. So you just need to find out the pressure of the oil at the bottom surface of the piston. And this is the whole diagram which they are talking about.
So, sir, just force divided by area?
Okay. If we use the concept of force divided by area, so that will give you the concept of pressure. So pressure will be equal to force divided by area. So force is equals to 8800 divided by area. Area will be equal to 0.016. So what is the answer of the pressure?
5.5 times 10 to the power 5.
5.5 into 10 to the power 5, right?
Yes.
Okay, so this is the pressure which we are talking about, which is acting on the piston, but they also mention the pressure of the air, that is the atmospheric pressure, right? Because normally in this diagram we observe that boxes are on the upper surface and there is a gap. So air will also apply pressure on the piston, right? That is the atmospheric pressure, right?
Yes.
So that's why we need to add atmospheric pressure over here. So our final pressure will be equal to the, let's suppose this is the pressure. So pressure of the piston plus pressure of the atmosphere. So we need to combine all these values, that is 5.5 into 10 to the power 5 plus 1 into 10 to the power 5. So that will be equal to 6.5 into 10 to the
Times 10 to the power
5.
5.
Yes. So that is the total pressure, pascals. Because this is very much important. So there is a gap, so it means air atmospheric pressure will always be there. So we need to add up the value of the atmospheric pressure, right?
Yes.
And part 2,
Because pressure is directly proportional to depth.
pressure is directly proportional to depth, okay, as the depth of the oil increases. So pressure is directly proportional to the depth, or if the depth will increase, so pressure will increase, or we can say that if we are talking about the liquid, so pressure will increase with the increase in the depth. So they are asking explain why the pump must exert an increasing pressure on the oil as the depth of the oil increases. Yes, so we are going in the depth, so it means we need to apply a greater pressure. So pressure increases with increase in depth or in the increase of the depth. So the upthrust force will act in the upward direction. That is by the force which is acted by the oil on the piston. So that is the upthrust force, right? In the opposite direction of the applied force. So to overcome that upthrust, so we need to increase our pressure. And the final part of this question suggests one reason why the force of 8800 Newton in B cannot lift boxes of weight of 8800 Newton. So they are talking about they are not able to lift the boxes. And in question they mentioned that the weight, or we can say yes. So the total weight of the box is equals to 8800 Newton in the question, and they are asking why it is not possible to lift up the boxes of 8800 Newton. So any idea why the force of 8800 Newton is not
Because both quantities would cancel out.
Yes, because both forces are equal and opposite, so it means we need to increase our force by 8800 to lift the box or to start the motion, right? So that is a simple concept. So force needs to be greater than force or weight of an object to lift the boxes in upward direction, right? Okay.
Yes.
Okay, question number 4. An aluminium saucepan with a plastic handle contains cold water. Figure 4.1 shows the saucepan on a hot plate. And state why the pan is made from aluminium but the handle is made from plastic.
Aluminum is a good conductor of heat, and
Aluminum,
plastic is a good insulator.
yes. So as compared to the property of aluminium and plastic, so aluminium is a good conductor and plastic is an insulator. So that's why we use aluminium and plastic. And part B, the hot plate is switched on and as the temperature of the water increases, the internal energy of the water increase.
So that's the increase in the kinetic energy of the particles.
Okay, that will increase the kinetic energy of the particle. So that's why the internal energy of the water increase. And state in terms of molecules again in this same paper, they again ask with the reference of the in terms of molecule. State in terms of molecule why what is meant by an increase in internal energy. So you mentioned that is the increase of kinetic energy because kinetic energy is directly proportional to the increase of temperature. So increasing the temperature means increase in kinetic energy of molecules, right?
Yes.
And in general, if you talk about the internal energy, so basically internal energy is the sum of kinetic and potential energy. So either there will be a change in kinetic energy or there will be a change in potential energy. So increase in kinetic energy or potential energy, right? And part 2, explain in terms of the atomic lattice and electrons how thermal energy is transferred through the aluminium. So now you need to explain with the formation of the electrons and with the formation of that material which we are using that is of aluminium, that how heat is going to be transferred through aluminium. That is
So
again,
aluminum has a positive lattice
okay,
with C a delocalized electron.
okay. So if we start writing for aluminium, so first of all, we know that aluminium is a solid. We don't need to explain in such detail with respect to the charge. So basically, they are asking with the reference of atomic lattice and electron. So you just need to explain in the terms of the structure and the energy transfer. So if we first talk about the aluminium, so aluminium is in contact In the diagram, you observe that aluminium is in contact with a hot plate, right? So aluminium is in contact with hot plate. So it will vibrate more faster, and atoms transfer energy. Atoms transfer energy because we know in solid molecules are easy and free to vibrate about its fixed position. They are not free to move from its fixed position. So atoms transfer energy with the help of vibration. And next, and in conductor, we also know that electrons are free to move, right? So energy can easily be transferred through the free electrons. So atom transfer energy due to vibration with the help of free electrons. So here is the reference of electron also. And the collision of electron will continue to transfer the heat, right? And the third part, eventually the water reaches boiling point. Thermal energy from the hot plate is still being transferred to the water. So now we are talking about the water which is in the aluminium container. So thermal energy from the hot plate is still being transferred to the water. Explain in terms of molecules. The effect of this thermal energy on the water.
Sir, would it have no effect because the energy provided would equal the energy released?
Okay, but now the liquid is very close to its boiling point, and thermal energy from the hot plate is still being transferred. So they are talking about that what happened after some time, because liquid reaches its boiling point. So in terms of molecule, explain the effect of this thermal energy on the water. So now our main focus is on water, it means liquid. So if we further increase the temperature or at this specific temperature, what will be the change in the liquid? Any specific change?
It will turn into gas.
Yes, because there is a process of evaporation because it happens at any specific temp, not any specific, it will occur at any temperature. So there will be a reference of the evaporation. So the very first point is that the molecules will evaporate or escape the surface of the liquid. And what will be the other change? Because we are still increasing the temperature, so the intermolecular forces or bond between molecules will be decreased or broken because of high thermal energy. So the bonding or the bond between the molecules of water and molecules gain potential energy because kinetic energy is directly proportional to temperature, and now it is going to convert into the steam, and the remaining energy or the remaining molecules, there will be a change or increase in their potential energy. So molecules gains potential energy that help them to overcome, right?
Yes.
This is the third part. So in this paper, mostly they ask about with the reference of molecule, with the reference of molecule. That is third time in the same question. And in part 4, the mass of the water decreases by 0.11 kg in 300 seconds. So most of the water molecules are evaporated. So we are left with only 0.11 kg mass in 300 seconds. The specific latent heat of vaporization of water is 2.3 exponent 6. Calculate the rate at which the water gains thermal energy. So we need to calculate the rate. So they are asking about the rate. And if we consider a simple formula for specific latent heat of vaporization, so that will be equal to latent heat of vaporization is equals to mLV. So first we need to find out, actually they are asking about the calculate the rate at which. So the word rate means we need to divide it by time, right? So we need to divide it by time. So
Yes.
this concept of ml over t will give you the value of rate. So we use the formula and the basic reference from specific latent heat, that is equals to ml. But for the specific quantity of rate, we need to divide it by that E by time, that will be equal to ml over t. So that is the concept. So mass is equals to 0.11 and latent heat of evaporation is 2.3 exponent 6 divided by 300 seconds. So that will give you the value of rate.
843.3.
843.3. Again, you need to round up to the two significant figure. What will be the value?
840.
840. So now try to practice to round up the value according to the two significant figures. Because now you know the formula, you know the calculation. So now focus on this concept of significant figures, right?
Okay.
Okay, so in this question, most part is related to the thermometer and that is not included in our new syllabus. So that's why we are going to skip this part. Okay, now let's try to solve this part of the waves. Figure 6,
Sir, can we do the next question? Because waves is easy.
question number 7.
Yes, it has magnetism.
Okay, so starting from question 7, figure 7.1 represents an alternating AC generator. A student rotates the handle edge as shown in figure 7.1. On figure 7.2, sketch a graph to show how the EMF between the terminals X and Y varies with time during two complete revolutions of the coil. Okay, so we need to draw a graph between, okay, EMF between two terminals X and Y. And we are using AC and we need to complete between X and Y for two rotation. Okay, so what will be the graph? So first we need to label the axis. So axis will be like this, that Y axis will be the EMF. And X axis represents the time because time is independent quantity. So that's why time is always plotted on X axis. Okay, so now there are two complete rotations. So you know the concept of the rotation or the wave or the oscillation, that when we are talking about the wave, rotation, oscillation, so two complete rotation means there are two crust and two trough, right?
Yes.
So it means that if you consider the concept of wave, so it starts from zero and the value of AC, it will be like this, crust. Because if you remember when we start this chapter and we discuss the graphical representation of AC and DC, so the graphical representation for AC will be like the sine waves, right? Just like the transverse wave. Okay.
Yes.
Okay. And on figure 7.2, mark and label a point P for the EMF where the coil is horizontal as shown in figure 7.1. So now again we need to find out a point on the graph where the coil is horizontal. Actually, they are talking about the same orientation. This is the parallel position. So parallel position mean coil is in the same line with the magnetic pole. So at this specific position, where will be the point P we need to mark on the graph? If you remember when we are working with DC and AC, so we discussed that in parallel position, the value of EMF will be maximum or the value of force will be maximum, right? If you remember the parallel condition.
All right, sir.
And if you don't remember, in the case of DC motor, or let's suppose if we talk about this AC, so that will give you the same concept for the DC. So now let's suppose if we start moving or if we start rotating this coil, so let's suppose if the force is acting on the right hand side of the coil will be in downward position, right? So we need to use the right hand rule to find out this specific concept. So we need to place our thumb in downward position. So thumb will be in downward position, that is the direction of force. And what will be the direction for the first finger? That is from north to south, right?
Yes.
So that will give you the direction of current in this form like this. If you place your finger just like your first finger is pointing towards right hand side, so this is the direction of the magnetic field, north till south. And for the specific direction of thumb, thumb will be in downward direction. And now the third quantity, which is the quantity of current. So that will be on Z axis. So if you place your right hand, because for AC generator, when we are finding the direction of the current or the induced current, so we use right hand rule. And when we are working with the DC current, we use left hand rule. So that will give you the direction of electric current on Z axis. somewhere at this point. So it means both of three of these forces are mutually perpendicular to each other. So always remember, at parallel condition or in parallel state, the force acting on the coil or the EMF induced in the coil will be equal to the maximum value. And when they are talking about the perpendicular condition, so in perpendicular condition, the induced EMF or the force will be minimum, right? Let's suppose if this coil rotates by 90 degree, so the two of parts of the coil are up and down in position opposite to each other, like up and down position. So in perpendicular condition, the induced EMF, or if we are talking about the DC motor, so the force on that DC motor will be equal to 0 or minimum, right?
Yes.
So that is the concept. So now we are using the parallel condition. So parallel condition represents the maximum point. So where will be the maximum point P on this graph?
The crust?
Yes. So either you just mention the crust or the trough, because both represents the maximum value. So we are using the crust. So that is the point P. You may also mention point P on the trough also, because trough also represents you the maximum value, right?
Yes.
Okay, moving towards the next part. The student turns the handle more quickly. State two ways in which the EMF between X and Y changes. So that is also simple. You just need to answer the factors affecting the induced EMF. So what are the two other factors? One, it is already mentioned, to increase the force or to increase the rotation on the coil. What are the other factors?
The type of magnet?
Yes, so we need to increase the magnetic strength of the magnet. And the second factor, increase magnetic strength. And part two,
The magnetic field?
okay, sorry, they are asking state two ways in which the EMF between X and Y changes. So they are talking about the change. So change means we need to reverse the pole of the magnets, right? So we don't need to write increase in magnetic field. We need to write change in magnetic poles. So if we reverse the magnetic poles, so that will change the EMF between terminals X and Y, right? So they are asking about the change. I read it wrong, that to increase the EMF between X and Y. So they are asking about the change in X and Y. So change in X and Y means to change the magnetic poles. And what is the second factor?
EMF increases?
Yes. Or further we can write it as increase the amplitude, because according to the graphical representation, if frequency will increase, so the amplitude will also increase. So increase or decreasing the amplitude will also change the EMF between terminals X and Y, right? Because the student is turning the handle very quickly, so that will increase the amplitude. If they ask that a student is turning the handle very slowly, so it means EMF will decrease. So they are talking about that a student turns the handle more quickly, so it means it will increase the amplitude. And the third point you mentioned, that EMF will increase. So that is also valid that EMF will increase. So remove the first point because that is for the change in the EMF. So EMF will increase and second, the amplitude will increase, right? And first point, that is the greater frequency. Terminals X and Y are connected to the primary coil of a transformer. State and explain what happens in transformer as the student turns the handle of the AC generator. So now it is connected to the primary coil of the generator, sorry, transformer. So you know that there are two types of coil. One is primary and second one is secondary in transformer. So we connected it with the primary coil and state and explain what happens in the transformer as the student turns the handle of the AC generator.
Transformer converts AC into DC.
Okay. But in transformer, we are getting the AC current, right? The purpose of changing the current, that is of diode. Diode will convert AC into DC. You just need to write the basic concept of transformer because we know that in transformer, we are having primary coil and we are having a secondary coil. So if someone asks you the working of the transformer, so how transformer will work? So if you remember, first, when current passes through the primary coil, because the basic structure of the transformer is like this, we connect this primary coil with the AC supply. So when current passes through the coil, it will generate magnetic field, right?
Yes.
So alternating current or the current in the primary coil. And what happen next after the magnetic field will generate?
EMF.
EMF will induced in the secondary coil. And what is the reason? AC in the primary coil will generate magnetic field. And we are talking about the alternating current. And alternating current always changes its direction. So due to that change in direction, the magnetic field will also change, right? So AC in the primary coil will generate magnetic field. And due to change in magnetic field lines, because we discussed the condition of parallel and perpendicular condition. So at parallel condition, the EMF will be maximum or the force will be maximum. So it means the field lines will be different at perpendicular condition, that is the minimum state of the force. So at that specific point, magnetic field will also change, right?
Yes.
So that will change the magnetic field line that is going to be cut by the secondary coil. And then the final step, EMF will induce in the secondary coil. And EMF will induced okay.
Yes.
Any confusion?
No, sir.
And if you want to revise the topic of this AC or DC, so let me know, then we will revise this concept in the next class. Okay.
Okay, sir.
And the last part of this question, explain why the power loss in transmission cables are lower when electrical energy is transmitted at higher voltage.
The resistance is low.
Yes, because we already discussed this concept in some papers. So at high voltage, the value of current is low. The resistance is also low, or resistance will also decrease because the value of current is small enough. So resistance will automatically decrease because of the magnitude of the electric current. So there will be less loss, or there will be less loss in the form of thermal energy. So less thermal energy loss during the transmission in long cables, right? So this is the concept.
Right, sir.
Question number 8. A student setups a circuit that includes a 12-volt battery, an 800 ohm resistor, a voltmeter, and a thermistor. Figure 8.1 is an incomplete circuit diagram because the symbol for the thermistor is missing. The thermistor is not mentioned in the diagram. So thermistor is connected between terminal P and Q. Complete figure 8.1 by drawing the symbol for a thermistor between P and Q. So what is the symbol for thermistor?
Sir, is it a variable resistor?
Yes, it is a variable resistor. So we just need to draw a symbol just like the variable resistor. It will be like this. Because thermistor will also act like a variable resistor, rheostat will also work like a variable resistor, and LDR has its own symbol, so the symbol for this will remain same. And the next part, the 12-volt battery consists of 8 identical cells connected in series. So now cells are connected in series. They are talking about the cells, not they are talking about the resistors. So there is a different concept for cells. If you remember that in series and in parallel combination. So let's see what they are talking about. Now you need to calculate the EMF of each cell. So there are 12-volt battery, and this 12-volt battery is made up of 8 cells, right? And if you in series combination, first you need to know that the EMF will increase, decrease, or what is the concept for the cell. Any idea that in series combination, the EMF of the cells are combined or different?
They're the same.
It means all will equal to 12 volts, all cells.
No.
Okay, so basically there is a very simple concept if you don't know about or if you don't remember the concept. So the concept is this, that the first state, if we talk about in series combination, so in series combination, if cells are connected in series combination, so the potential difference or the EMF will combine, right? So we use the concept of combined EMF, right? And the second
Yes.
concept, if we are using cells in parallel combination, just like in our remote control, mostly we use the parallel combination. So in parallel combination, EMF will remain same. Let's suppose if the EMF of one cell is equals to 1.5, so that two cells will also give us the value of 1.5, but that cells will retain for longer time as compared to the series combination, right? So normally we use parallel combination for long lasting concept. And if we want to increase the EMF, so we use the parallel combination in cell. So in this question, we are using series combination. So what we need to do?
We have to combine the EMF.
Yes. So basically, there is a battery of 12 volt and which is made up of 8 cells, right? So there is a battery, let's suppose, and it is made up of 8 cells, right? So there are total 8 cells in a battery. And this battery gives the output of 12 volt. So we need to find out the EMF of single cell. So how we calculate the EMF of a single cell?
12 divided by 8.
Yes. So we need to divide 12 volt among all 8 cells which are connected in series. So EMF of a single cell will be equal to 12 divided by 8. That will be equal to 1.5 volt, right?
Yes.
And the reading on the voltmeter is 8 volts. Determine the resistance of the thermistor. So we are having a reading on voltmeter that is 8 volt. So let's again check the diagram, that how diagram represents. So they are talking about the resistance of this thermistor. Do you remember the formula for the potential divider that divides the voltage?
Work over charge.
No, that is for the EMF. Okay, so there is a simple formula, don't worry. The formula for the potential divider is like this, that if you need to calculate the output voltage, that is the output voltage which are getting on thermistor. So to calculate that output voltage, first you place the resistance, which is unknown in numerator, like this. We are going to find out the resistance of thermistor. So we write RT. And in denominator, we just divide the value of both resistor which are connected in series, because these two connect resistors are connected in series. So that's why we combine the resistance, that is RT plus 800. And this whole quantity will multiply by the input voltage. And that input voltage is 12 volts, right? So any confusion in this formula?
Understood.
So this is a very common formula for potential divider. Just keep the value of resistor which is unknown on the top and remaining value in the denominator and multiply by the input voltage. So let's rewrite this formula over here. So the output voltage will be equal to the resistance of thermistor divided by resistance of thermistor plus 800 ohms multiplied by the input voltage. So the output voltage is 12. So 12 multiplied by RT plus 800. And on right hand side, we are having RT multiplied by the input voltage. Oh, sorry. The output voltage is equals to 8 because they already mentioned this is the output voltage. So output voltage is equals to 8 and input voltage is equals to 12. So now multiply the values, it will be like 8 RT plus 8 is the 64 is equals to 12 RT and 6400 is equals to 12 RT minus 8 RT, that will be equal to 4. And this 4 will divide on the other side. So what will be the final answer?
1600.
1600 is the final resistance, that is ohms, right?
Yes.
Explain. A few hours later, the student noticed that the reading on the voltmeter is greater. Right? So now a student observed that the reading of the voltmeter is greater. Explain what can be deduced from this observation. So there is a thermistor. So there are multiple possibilities over here. So think about the thermistor, that how thermistor works. Thermistor actually works on temp.
It's variable.
It's variable resistor, and the thermistor is a component which works on the temperature, change of temperature, right? So if we increase the temperature, so what will happen?
The value would increase.
Okay. So if we increase the temperature, so basically in thermistor, if the temperature will increase, so resistance will decrease. If you remember that concept of Ohm's law, that in Ohm's law we discuss about filament and thermistor. So temperature increases with temperature with resistance increase in filament, but in thermistor it is opposite. That if we increase the temperature, so resistance will decrease. So if resistance will decrease, so the value of electric current will increase, right? And the value of voltage will decrease. So it means that if to increase the value of voltmeter, so temperature must increase or decrease?
Decrease.
Decrease. So we need to decrease the temperature, so that will increase the voltage and that will also increase the resistance. So first factor is that it is might be possible that the temperature of the thermistor will decrease. Temperature of the thermistor will decrease, and if the temperature of the thermistor will decrease, so the voltage
Resistance would
will
decrease.
decrease plus resistance will also decrease, right? So voltage and resistance both will decrease. Okay. Okay, so that is reverse. Both will increase because in the above statement we discuss if the temperature is increased, so resistance and voltage will increase. So basically thermistor will work in the opposite way as compared to the filament because in filament temperature increases with. So that's why in thermistor, if the temperature will decrease, so voltage and resistance both will increase. So increasing the temperature will increase the reading on voltmeter. Any confusion, any question?
And no, sir. It's all clear.
Okay. And if you want to revise this topic, so let me know in next class, we will revise this topic. Okay. Question number 9. There are three naturally occurring isotopes of hydrogen, hydrogen 1, 2, and 3. The nuclide notation for hydrogen is 1H1. Write down the symbol using nuclide notation for hydrogen 2 and hydrogen 3. So in this question, they are talking about the isotopes of hydrogen, that is hydrogen 2 and 3. So we know that according to the definition of isotopes, the number of protons will remain same, that is the proton number or the atomic number will remain same, but the number of nucleons will change or the atomic mass will change. So according to that condition, the equation for hydrogen 2 will be written as the proton number will remain same, but the number of nucleon will change, that will be 2. And for hydrogen 3, that will be 1H3. There are two number of neutrons in hydrogen 3 and one number of neutron in hydrogen 2. Okay, in fusion reactor, a nucleus of hydrogen 2 and a nucleus of hydrogen 3 undergo fusion state. What is meant by fusion reaction? So fusion reaction means to combine two small nuclei to make a larger nucleus. To combine two small nuclei and make a heavy nucleus. Question number 9b, part 2. The fusion reaction produces a free neutron and one other particle. Write down using nuclide notation the equation that represents this equation. So now we have to write a equation for this whole reaction. The fusion reaction produces a free neutron and one other particle. And write down using nuclide notation the equation that represents in this equation. So we know that in the previous part that hydrogen 2 and hydrogen 3 are going to combine. So in the reactants we have 1H2 plus 1H3 because these are going to combine with each other, and the final reaction will be like this: a free neutron and one other particle. So we are going to add a neutron over here. For neutron, we know that there will be no number of proton or zero number of proton and one number of neutron plus one other particle that is unknown. And but you need to fill the number of protons and number of neutrons for this particle. So there is, or there are two total number of protons for this particle, and one new number of neutron is already taken by this neutron. So that's why we left out only with 4, because here we have 2 plus 3, total 5, and subtracted by 1, so we will get 2 over here. And it is most probably like helium, because we know that this is the alpha particle, and alpha particle mostly we consider it as a helium atom. So you may write helium over here rather than writing X. And part C is nuclear fusion in the sun is the source of most, but not all, the sources that are used to generate electrical energy on Earth. State two sources for which nuclear fusion in the sun is not the source. So we need to write two resources for which nuclear fusion that was happen on the sun is not the source. So we need to write the sources which are not responsible for nuclear fusion. So the first one is geothermal energy. And the second one is the tidal energy, or we may further write nuclear energy. So these are the two resources which are not the source in the nuclear fusion on the sun. And the final question is related to waves, which we left out, and we solved first the question of electricity. So let's solve that remaining question of wave in this paper. Okay, so in question number 6, figure 6.1 is a useful scale diagram that represents a sound wave traveling in air. And on figure 6.1, mark 2 points each at the center of a different compression, label both of point C. Okay, so in 6.1, we need to mark 2 points each at the center of a different compression. So first we need to find out the compression. And for compression, we know that both sides will be same around compression. So let's suppose if we start from the first one, so this is the part of compression. So in the first part, so let's suppose this is the center of compression. So this point represents C, because on the right hand side we have two equal wavelength, and on left hand side we also have two equal wavelength. Same goes over here. Here again we have compression, the same compression we observed in the start, or either we mark compression over here. There are multiple points, but you need to select only two. So basically there are 3 points given in the diagram, and the speed of sound in air is 330 meter per second. Measure the diagram and determine the frequency of the sound. So speed of sound is mentioned over here, and we need to find out the frequency. So the value of the wavelength is not mentioned. So we need to find out the wavelength with the help of the diagram. So that will give us the value of the wavelength. So basically you need to use a ruler over here to find out the value. So I already calculated the value, but if you need to find out the wavelength, so you just need to measure the length. Let's suppose if you measure this length, then find out the number of waves, 1, 2, 3, 4, 5. Total 5 waves are going to complete over here. So divide the length by 5, so you will get the value of the wavelength. So the value of frequency will be equal to V over lambda. So V is equals to 330 meter per second divided by the wavelength. That is 0.052. So that will be equal to 60. around 6200 hertz. You may calculate according to your length, because in marking scheme it was ranging between 6200 to 6500. Okay, so part C of this question, the waves reaches a barrier 6.2, shows the wave passing through a gap in the barrier, and the frequency of the wave is increased to a value many times greater than the value obtained in B. So describe and explain two ways in which a diagram representing the wave with the greater frequency. So we need to just justify the statement with the reference of the greater frequency, that how frequency is going to be increased with the reference of the above diagram. So if frequency will increase, so we know that increasing the frequency means there will be a greater number of waves in a unit time. So it means we need to first check the compression part. So let's suppose if this is the compression, and if we compare the compression over here, so you observe that the distance between the waves is now decreased, right? So the first identification is there are a greater number of waves in compression as compared to the previous part, because this length is something different as compared to this one. So now length is short. So the first statement is either you write with the compression or with refraction. So compression of the waves are close to each other or distance will decrease. And for the second point, there is less diffraction, because if we increase the frequency, so wavelength will decrease. So to increasing the frequency, the wavelength will decrease. So it means that decreasing the wavelength means we need to increase the frequency. So if we increase the frequency, so wavelength is going to be decreased. So the second point is, that is the second identification, that less wavelength means there will be less diffraction. So less diffraction because wavelength will decrease. So this is the complete solution of this whole paper. Okay. So next time we will continue with the next paper. Okay.